guys, welcome once again. Today we are using the superposition theorem to calculate the current flowing through the 5 ohms resistor. And in this diagram we have how many sources? We have two, a voltage source and a current source, so we can apply the superposition theorem. So first of all, let's work with what? The 10 volts and deactivate the 2 amperes so that we can find the first current flowing through the 5 ohms. Later we will let the 2 amperes act, then we deactivate the 10 volts, then calculate the current flowing through what? The same 5 ohms. Then we superimpose the two results. So we start with let 10 volts act. So if 10 volts is acting, that's the source we are having now, 10 volts. We have this 10 and what? This 40 connected here. We have this 3. We have our 5 here. We have what? 2. And this is where the current source. So we are going to open circuit that branch because we are deactivating. So what do we have? We have 2 ohms, 5 ohms, 3 ohms, 10 ohms, and what? 40 ohms. This is our source, 10 volts. Now we are going to use this diagram to calculate the current flowing through the 5. So in what direction will the current flow through the 5? It will be based on the total current coming. So if total current is coming from here, that current will get to this junction. It will split here and here. The remaining current here will get to this junction. But when it gets here, on this branch, it has been what? Open circuited. So no current is going to flow there, meaning the resistance here is what? Infinite. So no current is going to flow on this branch. So the current through the 3 will end up flowing through this 5. So the current in the 5 is moving downwards. And I'm going to call that current I naught prime. That's the first current I'm going to find, I naught prime. So I'm going to use the network reduction method to calculate the I naught prime. Someone can also decide to use what? The mesh current method, the star delta method, the source transformation, any method that comes into mind. You can use it to calculate the current through the 5. So let's do the network reduction. So we are not going to include these two because the current didn't flow through. So we have this 5 and this 3 connected in series because the same current flow through them. And also this 10 and this 40 are on the same branch. They are also in what? Series. So I can find the equivalent here, the equivalent here. So the equivalent, let's say RA is for 10 and 40 in series, giving us what? 50. Let me call RB to be the equivalent of 3 and 5, giving us what? 8. So the equivalent of this is RA, the equivalent of this is what? RB. So my circuit now looks like this. I have my voltage source, I have what? RA, and I have my what? RB. Good. So this is what we have now. So our source is 10 volts, our RA is 50, our RB is what? 8 ohms. Now you can see that these 3 elements are connected in what? Parallel. So we know that elements in parallel also have the same voltage across them, meaning the voltage across the 50 is the same as what? The source voltage. The voltage across the 8 is also what? The same as the source voltage because they are all in parallel. So I can say that the voltage for the 8 ohms is what? 10 volts. I'm working on the 8 because the current I want is the current through the 5, and that 5 is joined with the 3 to give us the 8. So I won't bother with the 50. I'm just focusing on what? The 8 ohms. And I know its voltage to be 5. So I can use Ohm's law to calculate the current through the 8. And from Ohm's law, current through the 8, let's call it I8 ohms. It's what? V over R, and the V is 10 over what? R. So we have what? 5 over 4 amperes. So the current flowing through this 8 ohms is what? 5 over 4 amperes. Now this 8 is also from where? From 3 and 5. In what connection? Series. Meaning the current in the 5 is also 5 over 4 amperes. And that is the I naught prime we are after. So now I can say I naught prime is equal to 5 over what? 4 amperes. Very simple. So we found that current. We are going to work with the other source, which is the current source. Then we will deactivate this source. So let the 2 amperes act. So let 2 amperes act. So if 2 amperes is acting, I'm going to deactivate this, and in deactivating a voltage source, we have to represent it by what? A short circuit. So that portion looks like this. We have a short circuit. Let me represent this portion. We've already done it. This portion by what? Its equivalent, which is 50. So I have the 50 here. I have what? This 3 here. I have this 5 here. I have this here. And I have what? My current. So 2 amperes, 2 ohms, 5 ohms, 3 ohms, and what? 50 ohms. So we are going to use this diagram also to calculate the current flowing through what? The same 5 ohms resistor. But in which direction is that current flowing through what? The 5. We are going to apply the network reduction method here. So we can see that the total source is what? The current. The source here is the current. So that current is moving in this direction. It is moving through what? The 2 ohms. When it gets to this junction, there is a branch, there are resistors on, so the current will have to split. So some will pass here, some will pass here. So the one flowing through the 5 is going down, and I'm going to name it what? I naught prime prime. Any name you want, you can give it to it. So let's continue. This current flowing through the 3, now it gets to this junction. Good. So when it got to that junction, it met how many branches? It met 2 branches. And it realized that on this branch there is 50 ohms. But this branch is what? Short circuited, meaning the resistance here is what? 0. So a short circuit has 0 resistance, and open circuit has infinite resistance. So since the current sees that there is a branch with 0 resistance, it means that current is going to avoid the resistance here and pass through that other branch. We've done this in our network tutorial too. We did it in that video. So we realized that the current will flow through this short circuit and avoid this 50. So no current is going to flow here. The current through the 3 will continue its way and flow through this branch, get back to this portion here, meet up with this I naught prime prime, then that same 2 amperes will go back. So we are going to avoid the 50 ohms. So you realize the current 2 amperes passed through 2 got split between what? The 5 and the 3. Meaning the 5 and this 3 are connected in what? Parallel. That's the end of the circuit, because we are not going to include this. And we have the source to be current, so no need for us to calculate total resistance here. We did the total resistance so that we can get total current, then do the current divider. But in this circuit, the current is already given, so we just have to apply the current divider to the resistors in parallel. So I can apply the current divider here and calculate what? I naught prime prime. So the current divider between 5 and 3, I want for the 5, so it is the opposite, 3 over what? 3 plus 5 times the total current. So this is giving us what? 6 over what? 8. And that amperes. So 3 over what? 4 amperes is my what? I naught prime prime. So the current flowing through the 5 ohms when the 2 amperes is acting is what? 3 over 4 amperes. Now we are going to find the total current I naught when both sources are intact. And that I naught is equal to. So this is where we realize that from the circuit, the I naught given is moving down. Meaning when each of the sources are acting, the one moving in the same direction, that is moving down, should be positive. If one of them is moving up through the 5, it should be considered negative. So when this one was acting, the I naught prime was moving down. When this one was also acting, I naught prime was moving down. So we are going to sum the 2. So we have I naught prime plus I naught prime prime. And that one is giving us what? 5 over 4 plus 3 over 4. And that one is equal to what? 8 over 4, which is what? 2 amperes. So the current I naught is equal to what? 2 amperes. That's the current flowing through the 5 ohms resistor. So in exams, they can ask you, a first question will ask you to calculate the current flowing through that resistor when this source is acting. That can be one question. The next question can be calculate the current flowing through that same resistor when the other source is acting. That can also be the next question. And the last question can be calculate what the total current flowing through that resistor when all the sources are working. So expect those type of questions in your exams. Thank you very much for watching this tutorial video.